We will solve the following exercise. The exercise is the number 2.15. The vector r extends from point A to the midpoint between points B and C. Prove that this equation is real. R is equal to 1 divided by 2 multiplied by the summatory between RAB and RAC. Alright, so what we have right here is principally two summatories of vectors. How's that? Well, the first one is, bear with me, this summatory. Alright, remember that, and this is something that we have seen for the entire chapter. For when we want to create a summatory of vectors, for example these three, all we have to do, graphically speaking, is create a resultant shape, a resultant vector. And the requirement that we have to meet is that the tail of the vector must be touching the head of the other vector. Alright, right here I have, for example, this one, but remember that the order is not important, right? Because the answer is going to be the same one. I just have to meet the requirement that I just said. And the result will be the connection between these 2 points, between the corner vectors in this case. And this vector is going to be generated the other way around. The head must be touching the head and the tail, right? For example, for these 3 vectors, my answer will be this magnitude. Alright, so they are telling me that I have right here one vector, RAC, and right here one second vector, RAB. They are telling me also that the vector R is generated from point A to the midpoint of actually between C and B. Alright, so this is one summatory that is happening right here. As you can see, I can call this point, for example, X. I always call my unknowns X, but that's not the point. So as you can see right here, RAC plus RCX, for example, I'm going to call this vector RCX, is going to be equal to R, right? And the same thing goes for this one. As you can see right here, RAB plus RBX is going to be equal also to R, right? So let me write down this information. RAC plus RCX is equal to R, and RAB plus RBX is equal to R, right? So we have our first and second equation. This third equation that we are going to use is one that appears taking into account this magnitude. As you can see, they are telling me that R extends from point A to the midpoint, and this is the important part, between points B and C. So I can be sure that RCX and RBX is going to be the same, at least talking about the magnitude. Why is that? Because as you can see, the direction of this vector is going to be opposite to this, right? And it depends on the author. Maybe I say something like, okay, I want that in this direction every vector is going to be positive. That means that this vector is positive but this isn't, right? Or I can say the other way around. I can say that this is positive. That means that this vector is positive, sorry, but this is not. So I'm going to assume, for example, that one of these two vectors is negative, right? For example, I don't really care about it. I'm just going to select one. For example, RBX. Right? So RCX, the magnitude, is going to be equal to RBX. Right? But just talking about the magnitudes. Hence, the direction is different. Hence, the symbol is different of one of them. RCX is going to be equal to minus RBX, for example. Or, as I was saying before, this is also true. It depends on the point of reference. I said it again if you do not understand what I'm saying. Alright, so this is going to be my third equation. Why is that? Because right here I can see that RBX plus RCX is going to be equal to 0. Right? So first, what I'm going to do is to solve one of these equations. I don't really care which one. For example, I'm going to select the equation number 2. So from equation number 2, from equation 2, I'm going to solve the equation for this vector RBX. That means that RBX is going to be equal to R minus RAB. And this is going to be my equation number 4. Right? But RBX has an equation right here. Right? So I can say that minus RCX is going to be equal to R minus RAB. Right? But this is a different equation, so I'm going to call it equation number 5. So I already have this equation, this equation, this equation, this equation, and this equation. I have 5 equations. What I'm going to do next is to solve this equation for RCX, but for the positive number, RCX. That means that I'm going to change the values, well, not the values, the symbols of every single part of the equation, right? So RCX is equal to minus, okay, to plus, but I'm not going to write down that, RAB minus R, right? And this is still my equation number 5 because I just changed the numbers, the symbol, sorry. So I'm going to replace this equation in equation number 1. Okay, because it's the one that I've not used yet. I already used number 2, I already used number 3, I already used number 4, but I've not used equation number 1. So that means that RAC plus RAB minus R is equal to R, right? All I have to do is to replace this part within this unknown, right? RCX in terms of RAB and R. So all I have to do is to play with this equation that I'm going to call, for example, equation number 6, and that would be all. RAC plus RAB is equal to R plus R, right? Because I have right here one R, so I just have to send it to the other side of the equation, but with a positive sign. with a positive symbol. That means that RAC plus RAV is equal to times R, right? That means that R is equal to RAC plus RAV divided by 2. And this is the same thing as having R is equal to 1 divided by 2 multiplied by the summatory of RAC plus RAC. Sorry. My mistake, my bad. RAB. Just that I'm saying a lot of R. And this is the same thing that we needed. As you can see, this is the same thing as this. Right, guys? So this is everything. This is actually how you could solve this exercise. There is no way in which we can well, actually there is, but we have to invent some numbers. But as you can see, I've made the step by step for you to realize that there is no mistake right there, right? That's all, guys. I like to thank you for your time, and I see you in the next video.